So today we're going to talk about dilations, but in general, we've been doing transformations. We've been changing position. That's translations. That's reflections. Today we're really going to talk about size and shape with a dilation. The symbol for a transformation is an arrow. You'll see that arrow. And we've already talked about pre-image and image, but I want to define it again. Okay? So if we have triangle ABC, and I need to translate it, you'll see A prime, B prime, C prime. And I know some of us have not been labeling, so please label with the new primes. Okay? Doing good? Image is the first one. So in this, my pre-image is ABC. My image is A prime, B prime, C prime. It's after the transformation. And today we really are going to talk about a dilation. A dilation. Okay? A dilation is an enlargement of a shape or a reduction of a shape. So like I said in the learning target, reduction, that could be shrink. Enlargement, that could be expand or get bigger. Okay? Today we're going to talk about a scale factor. A scale factor is a number that we multiply. We multiply by. And we're going to talk about specific scale factors. Ones that make shapes bigger, ones that make shapes smaller. The scale factor is bigger than 1. An enlargement is when our scale factor, the number we multiply by, is greater than 1. A reduction is when the scale factor is less than 1. And we usually say between 0 and 1, we will not have a negative scale factor. We will not have a negative scale factor. A dilation rule is a point A that has x, y, and follows the dilations. We always do this centered around 0, 0. And we have a scale factor of n. N just stands for a number. N just stands for a number. And I can write the rule n times x, comma, n times y. Remember, n stands for number. And notice how I have multiplication. Okay? I think it's important to add that we are multiplying. We are multiplying. Which is why I had you guys grab calculators today. In our first couple examples, we need to identify if it's an enlargement or a reduction, and then find the scale factor. So I've got triangle ABC. Why don't you highlight ABC with your highlighters, please? Is 7. So I'm going to say AC is 7. I'm going to say A prime, C prime. What's the length down here, the total length for the bigger triangle?
28.
Good, 28. And sometimes I find it easier to identify the side. And so now I'm thinking from 7 to 28, did we get smaller or bigger? Bigger. And by how much? What did we multiply by? We added 21, but what do we multiply by? If you're not sure, do 28 divided by 7 in your calculator. If you're not sure, do 28 divided by 7 in your calculator. We have an enlargement.
Can I use the
4. 4 times 4. So you're right, this is going to be shrinking because this is my original. The smaller one is my new one, so we can say it's going to be a reduction, or you could just say it's getting smaller. And I'm going to go with the side that I can easily count. Do you see how A to D I can easily count? I can count that on my graph. Let's count. It's 1, 2, 3, 4, 5, 6, 7. So AD was 7 units. A prime, D prime, we're going to count. It's 1, 2, 3 and a half. It's 3 and a half. Okay. Now this one's a little trickier. I'm going to take the new side and divide it by the old side. So I'm going to do 3.5 divided by 7 in my calculator. Can you do that for me in your calculator? Let's see what our scale factor is. Try that again. 3.5 divided by 7. What'd you say? 0.5. 0.5. Because our scale factor is less than 1. It's getting smaller. Common mistake is to flip these. Okay, and you would get 2. But that can't be true because our scale factor has to be less than 1. How do we feel about identifying a scale factor? If you're ready, flip the page. If you're ready, flip the page. We got a couple more examples and then we'll work on some homework. All right. We're going to use a dilation rule. I've got the images drawn for you. To do the dilation rule, the easiest thing is to use the points and the rule. What are we multiplying by here? What are we multiplying by? 3, good. And I'm going to write out the points. Where is A? At X is what? 1. At Y is 2. And then to get to my new points for A prime, what do I do with 1 and 2? Multiply by what? Yeah, multiply by 3. 3 times 1 is 3. 3 times 2 is 6. We'll graph it here in just a minute. I'm going to go point by point. B is at -1, 0. This is why we might need our calculators. -1 times 3. Yep. What's 0 times 3? It's just 0. Okay. When we're on the x-axis, if I'm multiplying by 0, it's not going to change. How about point C? Where is the original point? 2, -1. Great. And we're going to multiply that by 3. 6, -3. Now we're going to graph these new ones. Here's A prime. Here's B prime. Here's C prime. Now that I have the points, I'm going to connect them. Can you take a second? Graph it on your paper. Make sure you have the points and the new shape. In your calculator, do 1 divided by 4. Sometimes it's easier to convert the fraction. Sometimes it's easier to convert the fraction to a decimal. So if we do 1 divided by 4, we will get 0.25. So we're multiplying by 0.25. Will we have a smaller shape or a larger shape? Smaller, okay? And I'm going to list out the points. So this is at 2, 4. Again, I'm going to multiply by 0.25. So in my calculator, you're going to do 2 times 0.25. Can you do that in your calculator, please? Let's see what this first point's going to land at. Let's do this first point together. 2 times 0.25. What do you guys get in your calculator? 0.5, thank you. 0.5. And then to get the y value, I'm going to do 4 times 0.25. Can you do that in your calculator? What are we going to get? 1. And so now I'm going to graph this point. It's at half, which is right in between 1 and 0, and 1. So here's A prime. Let's do that with the next point. We've got B. B is at 1, 2, 3, 4, 5, 6, 7, 8. B is at -8, +2. You're going to do -8 times 0.25. You're going to do +2 times 0.25. Where is point B going to land? Point C is at 6, -3. So again, to find this point, I'm going to do 6 times 0.25. I'm going to do -3 times 0.25 to get point C. This one's got 1.5 and -0.75, which I know is a little trickier to graph. Yep, so 1.5 negative, so it's about here. Do your best to graph it. We'll connect our 3 points, and our triangle got smaller. I think it's important to note that for dilations, we are changing size. There's going to be a question on your tests. For dilations, the size changes. I would write that at the top of your paper. For dilations, the size changes. For translations, reflections, rotations, we're not changing the size. We're just changing the position on the graph. We've got one more example. Does anyone still need more time with graph B? One more example, okay? And there's one in your homework just like this. Finding a scale factor and applying it. We know segment AB is transformed from A prime, B prime through a dilation. A is located at 22, -18. A prime is located at 33, -27. So first we need to find the scale factor. I'm going to do my new divided by my old. So I'm going to take my new x value and divide it by my old one. Can you do that in your calculator? My A prime x value divided by my old one. What's our scale factor? What'd you say? Yeah, our scale factor is 1.5. So is our shape getting smaller or bigger? Yeah, our shape is going to get bigger. So we found the scale factor. That was step 1. Now we have to apply it. If B is at 814, we need to find B prime. What should I do to the x and y values to find the new ones? Multiply by what? Good, let's do it. We're going to do 8 times 1.5 to get my new x value. We're going to do 14 times 1.5 to get my new y value. Can you find our new point? Fantastic. Here's our new one. Questions? That's dilations. That's the unit.